Thank you. Now let's have a look at PLANTSIGHT and 3D immersive simulation. So under this theme track of digital transformation, I want to address the importance of the digital twin here. The real digital representation of the real plant. So what we look at is the information which is created in the very early phases of an engineering project, which will then be handed over, providing the benefits for operations phase. And the benefits there are for all stakeholders, from the highest role regarding the plant operations to those other important roles regarding maintenance, process production, inspection, and modification. We take this reference statement from ARC Advisory Council. They say that true digital twins must bring together context and characteristic data with real-time and operational data, because that's where the value is found in a true digital twin. If we look at the digital representation here, we can break this down into a granular part. So we can look at a single asset, or we can bring a number of assets into the process that they're part of, or the system that they're part of. And then we can use all of those systems to build up to an entire plant, so that we have a full digital twin representation of the real operating facility. And the important part about this is when changes occur, whether it's from the automation system making changes or whether it's from engineering driving change, it's extremely important that this information is recycled and continuously fed back into the digital twin. That means any changes done in the automation system are fed back into the digital twin, and anything done in the engineering authoring systems are also brought back into the digital twin. And I'll elaborate a little bit on this topic as we move forward. The most important value here is to be able to generate reliable insights around predictability and performance, in order that any changes for optimization, maintenance schedules, the recommended maintenance schedules, or what's looking like we can't wait until that time, that we have those insights to make reliable decisions. So the asset integrity, extremely important to monitor these critical objects, because without these, the availability of the plant is going to be impacted, production is going to fall, and we need to do some action there. Ideally, we want to look at this on a predictive level so that we can see from trends what's happening and be able to make some decisions along the way. The important part here is bringing all of the engineering, the static information, together in one environment, and then by connecting through sensory devices to the operating plant, we can do a comparison to say, this is how I'm designed to operate, and this is how I am operating. And we can make some analysis there, because over time, conditions will change in any plant, in any process plant, that will mean decisions have to be made based on that context that we bring together from one environment. So from Siemens, that environment is PLANTSIGHT, where we see on the left-hand side what I just referred to as the static data. That's the data which is coming from early designs, from 1D data sheets, from 2D documents such as PNIDs or other schematic drawings, and 3D models, in order that we can look at the object on the symbology on the 2D drawing and look at it in its actual physical environment so that we can make best decisions relating to all objects. When we look at the right-hand side here, we see this is from the DCS, alarm management, the real-time data which is being collected from sensory devices. This is such as noise, vibration. And then we look at the trending information, historical data. What do we know about this object in its system within the facility? And as we can see around the outside here, this is a continuous process through the life cycle of the plant. Traditionally, a handover is found at the end of the CapEx phase of a new development, what we refer to as in the EPC phase. With PLANTSIGHT, we can start that information handover continuously at a very early stage to give the stakeholders in operations a real view of the plant as it goes through design, into construction, through commissioning, and pre-production. And of course, plants having 30, 40 years upwards operating life cycle, then this is a continuous process as changes occur. Changes either from process conditions or from design changes. So before we go and have a closer look through some demonstrations, let me just position a few positioning slides for 3D immersive simulation. If we look at the left-hand side here of function and features, the 3D immersive simulation can be used for facility awareness training, personal induction training. So that's basically where you have people who are going to go onto your plant. They may not be permanently located at the plant, and therefore you need to do some form of induction training. So being able to immerse yourself in the environment, to look at operating data, as we've said earlier, and compare it with the static engineering data, could be beneficial based on the roles of that personnel going onto the plant. Immersive training simulation. So what we're addressing here is to be able to do maintenance planning and activities without the need of mobilizing a team onto the plant, and that itself addresses safety, efficiency, and getting things right first time. Inspection routines as well. A lot of the inspection necessary can be done remotely. We can capture images from CCTV, or if there are robotics on the plant, we can bring that information into our environment and improve our ability to do on-site work. Let alone evacuation processes. If incidents occur, then personnel should know the quickest and safest place to go to a safety refuge, a muster point or an assembly point. So looking at the benefits here, this will drive down the number of incidents on plants and keep your people safe. The schedule for carrying out the work on site will be protected, avoiding cost overruns, and ideally get it right first time. If this involves an outage of the plant, a downtime on the plant, then you will be up and running and the plant will be available faster without risk. And really, as PLANTSIGHT is a collaborative tool across all disciplines, all roles, it will allow you in an immersive way to bring those people together in one training environment to ensure that they work in a one team approach when executing the task on the plant. Let's look at the benefits within operations. So we've already stated about reducing lost time incidents because of human error. Human error being, I wasn't aware of certain things, where valve interlocks were located. It's driving out all of those things which the planning should take care of, therefore increasing efficiencies. Again, these areas here are addressing a learning by doing in a safe environment. So if we take one example of a team training, bottom right in this views here, this is bringing all of those multidiscipline roles together: the supervisor, the field technician, the maintenance operator, and any labor force that you need combined in a single environment. A great benefit here is that the learning instructor who is observing this training, he can intervene and start events, safety events, such as a gas release or a fire. And the intention there will be that the personnel don't react to try to fix that, but they do the safe thing and get to a safe point of refuge. And that is imperative to keep your people safe on the plant and deal with the incident that has occurred by the right people who are supposed to. Again, looking at some capabilities here, we're looking at standard operating procedures, which allow you to double check that the work packages that you've put together to do these is right first time. The HSE incident scenarios that your people will react in the correct way when incidents occur. The what if scenarios, essentially this is where you want to do some simulation between the field operator on the plant and the control technician in the control room using the OTS, the operator training simulator. So what happens if I close this without doing it safely? Will this lead to an incident? Before finding that out in a damaging way on the plant. The ways of doing this is either on a one-to-one training in an environment, on a desktop or a web-based training, or it can be inside a physical environment, a hive or a room with intelligent projector walls. Alternatively, we can use VR headsets in order that the individual is immersed in an environment. And again, that can be observed by an instructor who is following the simulation training. So if we look at a combined environment here, which PLANTSIGHT Immersive 3D Viewer, it will allow that trainee to immerse himself on the physical plant. He will be able to draw and pull down real-time information about the area where he is. Is this a safe area of utilities process, or is it perhaps a hydrocarbon area which is higher rated? Maybe even that maintenance is already in progress and he can see areas of the plant which are barriered with no access. Again, this is providing that immersive awareness and learning before you put your people onto the plant. So with that, I'd like to hand over to Andoni to go through some examples of immersive training.
So we are going to show a bit how the immersive environment can help when it's well integrated with our digital twin. Yesterday, for example, we saw that how the operational intelligence is aligned with our digital, when it's aligned with our digital twin, is giving us a lot of insights of what's going on in our facility. Now, let's imagine that we really want to get more in depth into the facility itself. So we get into an immersive environment, and we would like to get that same information when I'm immersed in this facility. The demo I will be doing directly on my desktop, but will fully work on a VR environment. But I will not do that on a live demo because it doesn't really look good. So from my digital twin, I will now go or jump to my immersive environment, which is this one. So this is our same facility, but in a more immersive environment. And what I will do now is I will try to find out the area where an alarm is being raised, which I can see here is on this system, which is highlighted in with the red status. Okay, so I will go into this area and I will try to find out what is going on this system. Okay, so for that I will select the element. I will remove my avatar so I can get a closer look. So this is directly coming from my digital twin environment, and I can get the information related to this pump. And I can see that there is an issue related to the performance of this plant, and there is a recommended action to do a regular maintenance cycle within 5 days, because the analytics predict failure within the next 10 days if bearings are not maintained. Okay, so this is a first example of how an immersive environment can already be used with the integration with all the digital twin information, and how this can be very, very useful to get insights not only about the information itself, but also how this is related in the area inside the plant. Okay, so now once I have seen this problem, then the next step will be, okay, now I would like to go ahead and do a short training on how to do the maintenance of this pump in order to be able to get familiar with the environment before I go on the field itself. Okay, so what I will do will be to start the scenario. I can start the scenario. In this case, I will directly start from here, from my toolbar, but I could also go back to my digital twin, and if I want to stop the work today and I want to come back tomorrow, I will just be able to go to my digital twin, and directly from there I will be able to start my training scenario. So now we are back into our digital environment, and as everything is very well integrated, we have our immersive training scenarios that are aligned with my immersive environment. In this case, we have 3 of them: startup pump P05202, plant familiarization, and emergency training. Okay, and as I said before, we could start directly from here, but just to speed up a bit the live demo, I'm going to start directly from our 3D model. Okay, so for that, I'm just going to reset the colors. So I reset the statuses, and now I'm coming to my drop down where I can see my 3 scenarios, which are aligned with the ones we saw in the digital plant, of course, in the digital twin, of course, and now I can run my scenario. Okay. So now we are in our typical training environment that we use, that our field operators will be using for training. I can start with the avatar or without the avatar, as I wish, so to be more or less immersive. All this, of course, works with our Oculus, and I invite you to go by our booth to get our latest video related to that topic, where you can see how all this training and basically the whole environment that we are demoing today can also be played or used on a VR immersive environment. So what I'm doing now is I'm following the steps that I need to take in order to be able to do our maintenance job on our pump. So for that, of course, I need to start first my secondary pump, so I don't have a loss of production. Now I will check, that here I have a drain, a small drain. So I will clean it up, and now I will go ahead to finalize or stop my pump to do the maintenance. Finally, I'm going to close my pressure valve, and of course I need to inform our control room that we are done with it. At the end of my maintenance training, I will get a small report to make sure if I have made a mistake or not, how long it took me, and so on. So I can also print it and save it to be uploaded to any server that I would like to. So with this, I would like to hand it over to Nigel. And as I said before, please feel free to go around our booth to get more insights and more information about our completely immersive and integrated digital twin environment. Thank you very much, Nigel, all yours.
Thanks, Andoni. So let's just close out this session by looking at some key takeaways. So with PLANTSIGHT, we can provide a rapid decision-making tool that looks at the digital plant in a holistic manner, looking at the engineering, design information, comparing it with the real-time operating, in order that operations and maintenance can be optimized, production also. And when we look at the analytics available through aggregation of information and visualization, these decisions can be made without the need to take the plant out of production and how to maintain a continuous high level of availability. So a final slide here, PLANTSIGHT in a nutshell, data which is found in different silos, different formats, needs to be brought together in one environment. So collect it, consolidate it. Collaborate across the workforce using a single web-based tool to make the decisions or give you those insights in order that the decisions that you make with confidence, and at the bottom here is an indication of some benefits and expected levels which can be gained with PLANTSIGHT. Thank you.